first section of chapter 6, we're going to be talking about exponential functions. Okay, so far we have talked about quadratic functions, radical functions, and now we're going to talk about exponential functions. What do you think of when you hear the term exponential? What math term is in that? Exponent, okay? So what these are going to look like, there's no specific parent function for these functions, okay, because they're all going to be different with each other. So this first section I want to talk about, and write this down on example 1 for me. First one we're going to talk about is f of x equals 2 to the x. Again, what do you notice about this function that I wrote down here? There's an x, but where's the x at? It's in the exponent, right? So that x value is in the exponent. So we're going to graph this function here. There's no trick to graphing these, nothing like that. So when we don't know exactly how to graph them, we always resort to our xy table. Yep, so go ahead and write your xy table down. We're going to go back to our generic 5 values. Remember, we want some negatives, we want 0, and we want some positives. So we're going to go -2, -1, 0, 1, and 2. You're always going to start with those 5 x values. Okay, now, what's the reason for those x values? How do we find the y values? Right, we would plug it into whatever that function says, right? So these numbers are going to go into there. So let's write these out because they can get a little confusing here. So if I'm plugging it into here, I'm going to start with that -2. I have 2 to the -2nd power. Now think back to last chapter. Can I have negative exponents? No. What do we do with the negative exponents?
Get rid of them.
How do we have to get rid of them? Think of this as over 1. We have to flip it, because if we flip it, that makes the exponent positive. So this turns into 1 over 2 to the 2nd power. So now let's just simplify this. What's 2 to the 2nd power? 4. So our y value for -2 is 1/4. So now we do the same thing for all the other values. 2 to the -1. Again, can we have negative exponents? No, what do I have to do? Flip it, so it turns into 1 over 2 to the positive first power. Remember, the only thing that's changing is that exponent becomes positive on the bottom. Okay. So then what is 2 to the first power? 2, yep, so this turns into 1/2. Now we plug in 0. 2 to the 0 power. Type that in your calculator. 2 to the 0 power. Anything to the 0 power. Write this in your notes somewhere, what I'm saying. Anything to the 0 power is 1 every single time. Okay, so write that down. Anything to the 0 power is 1, no matter what that base number is. Okay, anything to the 0 power is 1. So now we're moving on. 2 to the 1st. Do I have to flip or do anything with this? Nope. What's 2 to the 1st power? 2. And then 2 to the 2nd power is 4. So do you agree our table's filled out? Okay, so let's go graph those values now. So -2, 1/4, we barely go above that axis there. -1 to the 1/2. And then 0, 1, 1, 2, and 2, 4. Do it on that first graph, yep.
I hate that the numbers aren't here. It stresses me out.
Now, before I connect the dots and draw the line, okay, I want to talk about some things that we notice here. What's going on with this graph that I have so far? It's going up, okay? What's it doing as it comes to the left here? It starts to, what do you mean curve to a straight? Right, what she's saying is it kind of looks like this. However, someone give me a number less than -2 over here. What about like -5? Let's plug in -5 and see what we get. So if I come back over here, we have 2 to the -5. Again, I'm plugging in this value into my equation here. Again, can I have negative exponents? Nope, so this turns into 1 over 2 to the 5th. What is 2 to the 5th? 32. So what we get for our y value here is 1 over 32. Go graph that. Okay, so this over here, I'm at -5 right here, and that 1/32 is just barely above that x-axis. What do you think I would get if I plugged in -10?
It would all be above negative.
It's all going to be above that x-axis there. So this graph is never going to come below this x-axis. So draw your graph. It is going to get as close as possible to that x-axis, but it will never go below. So, but if I keep going in this direction, so like if I plug in 8, do you agree my value is going to be very large?
Yes.
Because that turns into 2 to the 8th power, right? That it gets very large. Okay, so our graph is going to continually skyrocket up to the top. Okay, so other things I want to talk about real quick with this graph, and you can go ahead and put this either by your graph or on your notes. I want to talk about domain and range. What values is domain? X values, right? So domain, when I come to the left, what am I approaching? Negative what? Infinity, yep. We hit negative infinity, and as I'm going to the right, I hit positive infinity. Good. With domain goes range. Range, what values are we looking at? Y. So here's my y-axis. What's my smallest y value? It is 0, right? This is the farthest it goes. Do we go anywhere down here? No. So our smallest y value is 0. What's my highest y value? Infinity, because it's going to keep going, right? Okay. 2 more things I want to talk about. Y-intercept. What is my y-intercept? Where it intersects the y. Where does that happen at? Right here. How do I write that as a y-intercept? 0, 1. And again, you're going to get that y-intercept. You can get that from your table. Whatever the x value is, whatever the y value is for x equals 0, this is going to be your y-intercept. Okay? And then one more thing I want to talk about is asymptote. We talked about this very briefly with radical functions. Okay? What does asymptote mean? Do you remember? Asymptote kind of serves as the barrier. Okay? Where is it being stopped? Where can the graph not go beyond? That's what it's asking. So asymptote, do you agree that our graph will not go below the x-axis? So our asymptote is that x-axis. So again, that asymptote is the line, it serves as a line where the graph does not go below or beyond. Okay? So we know that our graph will never come below here, so that serves as our asymptote. It's kind of a stopping point. Okay? On your graph paper, go ahead and write this right next to that graph so you know which one it is. The next graph I want to look at, this can be, you can still, okay, so this second graph, this is going to be f of x equals 1/2 to the x. First off, right off the bat, our first one, I'm going to write that up here, was f of x equals 2 to the x. Right off the bat, what's the difference that you see here? How did our base change? Our base number is a fraction now, okay? Did the placement of the x change? No, x is still in our exponent here. So what I want to ask you, what do you think is going to happen based off of our first graph that we had to this one? What do you think is going to change? How are they going to look different? Half the size? Okay. What else do you think? Any other thoughts of what you think is going to happen? Going to get bigger? Is it going to get smaller? Okay. Let's take a look. Remember, if you don't know how to graph things, what do we go to? XY table. So go ahead and make your XY table. Again, what are my values going to be that I use? -2, -1, 0, 1, and 2. So again, I'm going to come over here. What do we do with all of those x values? Plug them in, right? So I have 1/2 to the -2. Can we have negative exponents? No, so what happens? We have to flip it. What does 1/2 flip to? 2/1, and then the exponent becomes positive. So what's 2 squared? 4. Okay. And then we continue on. We have 1/2 to the -1. We have to flip it again, right? So this turns to 2 to the +1. 2 to the first power is 2. Anything to the 0 power is 1, always. Anything to the 0 power is going to turn to 1. Now we have 1/2 to the first power. Do we have to do any flipping? No, because our exponent is positive. What's 1/2 to the first power? It's itself, right? It's just itself. So then our next one is 1/2 to the second power. Again, you could type this in your calculator, but you can also think of distributing this to the top and the bottom. So this is going to turn into 1 squared over 2 squared. What's 1 squared? 1. 2 squared? 4. So this turns into 1, 4. So now that we have our full XY table, what do we do from here? We go and graph it. Yep, so here's a quick graph review. I'm going to plot -2, 4. So I start at 0, 0, and I go -2 in the x values. So I go to the left, -2 up 4. Now go ahead and do that to all of those coordinates there. What do you notice about this graph? I heard someone say it. It's going the opposite direction. Compare your two XY tables. What happened? The y values inverted themselves. Okay, so instead of increasing, your y values are decreasing this time. A question? Okay, I had a question. Where do you put 0, 1? Does it start at 0, 0? Does the x value move at all? No, because our x value is 0, so then you just go up 1. Okay, did our graph move at all? Other than being inverted? No, all it did was invert. What made it invert itself? Think of the difference between the graphs here. What made that graph invert? It's the fraction, right? Our bases changed. All it did was it did the reciprocal. It flipped. So that means our graph is going to invert itself. What's also going to happen with this graph? If I continue to plug in any of these values, it's going to stay above what? The x-axis, okay? What's going to happen as I continue this way? It's going to keep going up, right? All of these exponential graphs are going to look pretty similar to each other. Their direction and their starting point just might be a little different. Okay, so again, it's going to get as close to that x-axis as possible, but it will never, in this case, go below that. Okay. So let's talk about our key features again. So let's talk about domain. What is our domain? As we go to the left, what's happening? We're increasing to negative infinity. What about as we go to the right? Positive infinity. What do you notice about the two domains? They're the same. Domain's always going to stay the same with exponential functions. Okay? All right, range. What's my lowest y value? Again, here's my y-axis. Where's my lowest y value at? It's going to be that 0 point again. And then what's my highest y value? Infinite. Yep. What were the other two that we talked about? Y-intercept. Again, I can get that y-intercept from our table. What's my y-intercept? Yep, it's wherever x is 0. So 0, 1. And then last thing was our asymptote. Again, what does asymptote mean? What does it serve as? What does it do to the graph? You're correct. How do I know that it's the x-axis? That's where the graph stops. It does not go below that point. Okay, that's our asymptote. Our asymptote stops as a kind of blocking point. Okay, so in the first graph we started with, we had a whole number as our base number. Okay, and it looked like a regular exponential function to us. Okay, where it started at a minimal point and then it kept getting bigger and bigger. Okay, this one, our base turned into a fraction. Okay, we started big and then we got smaller and smaller and smaller. However, we're still not going below that asymptote. Okay, so example 3 that I want to do with you is your example 2a. It's that g of x equals 5 to the x plus 3. What do you notice about this one compared to the 2 that we've done so far? It's like an equation in the exponent, right? Okay, let's talk about this first. Our base number here, what's my base number? 5. So is my graph going to look like this, or is it going to look like this? Left or right? It's going to look like the one on the left, right? Because it's a whole number. It's not a fraction. So it's going to continue going up. It's bigger than 1. Okay? So, yes, we know specifically what our graph will tend to look like. Okay? So, but since we don't really know how to graph this, what do we need to go to? XY table. What x values am I going to use? Yep. So now I'm going to come over here. We're going to plug in these values. Okay. So this turns into 5 to the negative 2 plus 3. What do I need to do first? I need to simplify the exponent. Okay, so what's negative 2 plus 3? Positive 1. What's 5 to the first? 5. Yep. So this turns to 5. Now we do this for every single value. What's negative 1 plus 3? So we get 5 to the second power, which is 25. Okay. Now, remember we talked about anything to the 0 power? But what's happening to our... We're adding to that. So we can't say automatically it's 1 this time because our new exponent is 3. So what's 5 to the third power? It is 125. Yep. So now plug in 1. So what is my new exponent when I plug in 1? 1 plus 3 is 4. 5 to the fourth power? 625. And then last one here, we have 5 to the 2 plus 3. What's 2 plus 3? 5. Holy moly, 5 to the fifth power. 3,125. Now I heard, how on earth are we going to graph this? We're specifically not going to. I want you to do your best, though. So can I graph negative 2 to the fifth? Negative 2, 5. Okay, so negative 2, 5. Negative 125. Do you agree we're getting off the graph? Okay, just give yourself a point that you can go off of. Okay. Do you agree like this is getting nonsense here? Okay. But do we know our graph is just going to skyrocket forward? Okay, so from here, you know that this is just going to keep going up and up and up and up and up as it continues moving. Okay. However, the question is, what's going to happen this way? Let's plug in some other values. Let's plug in negative. I'm going to go a little farther. Let's do negative 8. Let's plug in negative 8. So if I plug in negative 8 here, this turns into 5 to the negative 8 plus 3. What's negative 8 plus 3? Negative 5. Again, we have that negative exponent. What do I do with negative exponents? You gotta flip it. So this turns into 1 over 5 to the fifth. And what's 5 to the fifth? 3,125. How do you graph that? 1 over 3,125. So if I come graph this over here, my x value is negative 8. So here I am at negative 8. What is this super close to? Type that in your calculator. Type 1 divided by 3,125. Right. What are we approaching? We're getting closer to 0, right? We're barely touching the line. If I zoom in all the way here, we're like right there. Okay, that's where my point is. Okay, it's like you can't even see it. See, as I zoom out, you can't even see it. Okay, that's really what's happening here. So do you agree I'm never going to go below this axis again? Okay, so go ahead and draw your line that way. I know that this is going to end up like this. Okay, and again, all I did was I checked that because what did some of you think when you got this value? Did some of you think it was going to stop here? Okay, so how we check that is pick another value just to see where it's going. Okay. So let's talk about behavior here. Domain. Yep, domain is always going to be the same no matter what your exponential functions look like. Okay, so we have negative infinity to infinity. What about range? What's my lowest y value? It is still 0 because we don't go below. Okay, so 0 to infinity because we're getting higher and higher and higher. Okay, you can know that because look at your y values here. Do you agree we're increasing? Okay. What was next? Y-intercept. Now, can we see that on the graph? No, so where can we get it from? The table. Right here, that's our y-intercept. 0, 125. And then what was the last thing? Asymptote. Again, what does asymptote mean? Like where it stops. Where does it stop? The x-axis again. And again, make sure you label your graph on your graph paper. Okay. So what I want to talk about real quick, what happened to our graph when we were changing our exponent value? When it's not just x up there. What's happening with that plus 3? It's adding to the exponent, and what did you notice happens to our y's? It increases very quickly. Do you agree? Okay, that's what this plus 3 up here is doing. It is drastically changing our y values at a much faster pace. Okay, rather than when we just had our x value there. Okay, so when your exponent's changing, it is drastically changing what your y values are going to be. Okay. Last one for today. It's your example 2b. It's that h of x equals 5 to the negative x plus 6. What do you notice about this one here? There's a negative exponent, okay, and there's this plus 6. Is that with the exponent or is it off? It's off by itself, right? So what do you think is going to happen with this one? Really, the biggest difference here we see is this. What do you think that's going to do to the overall graph? Okay, I hear go below the x-axis. What'd you say? You think it's going to stay the same? Okay, so again, if we don't know how to graph something, what do we do? XY table. Hey, wow. What x values am I going to use? Yep. Okay, so if I come over here, biggest thing to be careful with on this one is we have that negative up there. Okay, so when you plug this in, be careful. So when this turns into 5, we still have that negative, and then we plug in the negative 2 plus 6. Take care of that exponent first. What's negative 1 times negative 2? 5 squared plus 6. So, order of operations, we got to do that guy first. What's 5 squared? 25 plus 6. 31. So 31 is my y value for negative 2. Now we plug in negative 1. And what's my exponent going to be? 1. What's 5 to the first power? 5 plus 6. 11. Okay. When I see 0, can I just say 0? No. Is there such thing as negative 0? Nope, that just turns into 0 plus 6. What's 5 to the 0 power? Yep, anything to the 0 power is 1, but we still have that plus 6. So 1 plus 6 is 7. So let's talk about 5 to the first power plus 6. Well, what's 5 to the first? 5 plus 6. Thank you. Yep. Sorry, that formula up here has that negative up there. Thank you for noticing that. Right, what does this turn into since we have that negative exponent? That turns into 1 over 5 to the first, right? So type in your calculator 1/5, so 1 divided by 5, hit enter. And then add 6 to that. What do you get? Yep, and then change it to a decimal to make it easier on yourself. 6.2. Yep. Thank you for noticing that. So this one, last one, turns 5 to the negative 2 plus 6. What do we do with 5 to the negative 2? We got to flip it, so this turns into 1 over 5 to the second plus 6. Well, what's 5 to the second power? 25. So type in your calculator 1 divided by 25 plus 6. 6.04. Okay. What do we do once we have all of our points? We go over and graph. So again, you're going to fall off your graph. Just give you a nice starting point here. 0, 7, 1, 6.2. What do you notice about this one? What's going to happen as we continue doing values this way? What's going to keep going? It's going to keep getting higher and higher and higher, right? What's going to happen when we do more values this way? Let's try. Let's plug in 8. If I plug in 8 here, this turns into 5 to the negative 8 plus 6. Again, negative exponents. We have to flip. What is 5 to the 8th power? Wow. Really big number. Plus 6. Go ahead and type that. Take 1 divided by that huge number. Add 6 to that.
Would it all stay above 6?
Bingo. It's all going to stay above 6. This gives us 6.000000256. Okay, so do you agree, if I zoom in really far here, it's going to be right there. Getting as close to there as we possibly can. Okay, so what we just noticed, the farther we move to the right, are we ever going to go below 6? No. Okay. So now that we have our graph, let's talk about domain and range and all the other things. What's my domain always? Negative infinity to infinity. What's range? Where do I get the range from? In this case, can I get it from the graph?
Yeah.
Oh, I'm ahead of myself. Sorry. Range. What's my lowest y value?
6.
Some of you are saying 0, but do we come down here at all? Nope. What is it?
6.
Yep, it's 6. And then my highest?
Infinity.
Yep, because we're increasing. And then y-intercept. Now, we can get it from the graph or our xy table. What is the y-intercept? 0, 7. And then last thing,
How do we write that? 6.
asymptote.
6.
Right, can I just say 6?
No.
That doesn't make sense, right?
Sure.
So it's a line, right?
Yeah. The 6.
So it's going to have something to do with 6, but I need something in front of that. Something equal to 6. It is y equals 6, okay? The reason it's y equals 6, some of you might have said x equals 6, but that's here. Does that have anything to do with the graph? No, we want that y equals 6 because if I draw a line there, that's the line that I'm dealing with. Okay. All right, so come back to our equation here. Again, write this with your graph so that you can reference it later. What happened with this plus 6?
It just stayed. That is like our
That's your asymptote, right? This turned into what your asymptote is. Okay, if I think back to your first graph where it was 2 to the x, what was our asymptote? 0. That's because were we adding anything? No. Okay, what if I turned this into a minus 6?
be a negative 6.
Our asymptote would be at negative 6. Okay?
Lovely.
All right.